If you've been following along at all with the rebuild of my K&T horizontal mill, you may recall previous videos where I took the motor out of the machine and cleaned it up and reassembled it. That whole process was quite the task, not just because this motor is extremely heavy, but just because of how filthy dirty it was. I'll put a link in the upper right hand corner here for those other videos where I removed the motor and rebuild it. The task today now is to get it back into the machine and get it wired up. One of the things that I didn't catch on camera was the removal of the starting lever. The starting lever is keyed to this shaft and is used to start and stop the machine. This shaft also engages with the clutch that is attached to the main drive pulley. The shaft also acts as a conduit for the start and stop wiring for the motor. And while I had everything apart, I figured it made sense to go ahead and replace all the wiring while I was at it. The lever is keyed to the shaft, and it's a pretty tight fit. So I'm just using a dead blow here to drive it until the screw hole lines up with a notch in the back of the shaft. Once the lever is seated all the way onto the shaft, I'll insert this screw and tighten it, and that will clamp them together. With the starting lever clamped to the starting lever shaft, I can go ahead and reinstall this cover plate. I'm getting ready to rewire the start-stop buttons, but history has a tendency to tell me to be a little more cautious. So I'm going to put some string around these wires just in case they decide to fall down inside that shaft a little deeper than I can reach. As I mentioned before, these are new control wires. The original wires were solid wires. I've replaced them with stranded. I don't typically like to use stranded wire on a screw terminal, so I'm going to use some terminal lugs here and solder them to the ends of these control wires before attaching them to the start-stop control buttons. Some time ago, my wife gave me as a gift this butane soldering iron. I find I end up using it more than the one that is powered by the 110 volt outlet. It heats up faster, there are no wires. It just seems to be all around more convenient. She got it for me so I could have it in my Jeep when I'm out on the trail, should I need to do any kind of a repair that would require soldering wires together. I'd have it, but I find that I use it way more around the shop than I do when I'm out in the Jeep. And I always think it's a good idea to use heat shrink tubing on any kind of a terminal joint. And now I can go ahead and wire up this control buttons. Black is common, and green is for the start button, and red is for the stop button. When I first got the machine, these buttons were in pretty sad shape. I took this thing out and apart, cleaned it up real good, and then my son, who's gotten really good with a fine paintbrush, went ahead and used some white acrylic paint to redo the lettering. And personally, I really like the Art Deco styling of this cover. Well, before we can get the motor reinstalled, I need to get this motor base reconnected to the hinge pins. There are two arms on the motor plate. Each one has a hole bored in it for a hinge pin that mounts into the main casting of the column. Unfortunately, these things aren't in a very great spot, so I have to lay on my back in order to get myself in a position where I can get these pins placed in and then insert them into the accompanying holes of the column. I have to first start the pins in the motor base holes and then lift it up to where that they line up with the holes in the column and hopefully slide them through or drive them through into the column. Having the motor plate hinged is necessary in order to have some kind of a mechanism to adjust the tension on the drive belts between the motor and the main drive pulley. There are also two set screws that go through the ends of the arms on the motor base that capture the hinge pins in place. Well, the next step is to bring over the motor and get it in place to be ready to be bolted down to that motor base. Well, the first thing I need to do is fish the three power lines from the motor through the junction box inside the column base and then out the back. I can pull those all the way through then and then connect the flexible conduit from the motor to the junction box. This motor is pretty heavy, so it's going to take a little bit of doing to get this thing lifted up and slid onto the motor base. I got this piece of 4x4 post that might come in handy here. If I can at least get the front end of the motor on it, it should give me enough elevation then I can lift the back and then slide it in. Well, with the motor now inside the column, I just need to find the threaded holes in the motor base that match up with the screw holes in the motor. Of course, none of this helps that I'm in a confined space to start with. It's darker than it actually appears on camera, and I can't see the hole in the motor base, and I can't get a punch in it to where I can try to line it up. So I'm using a flashlight, a headlight, to try to get some something close, and then hopefully by putting the bolt through the motor, I can nudge it around enough and find the threaded hole on the motor base. Persistence does pay off. I don't think there is an easy way to do this, so just keep trying until you do it. Well, I finally managed to get both of the rear bolts into the motor base. I'm not going to tighten these up completely until I get both of the ones on the front started. In order for me to get reasonable access to the bolts on the front, I need to lift this motor plate up, and I do that with this bolt and jam nut. This is actually a lifting bolt that lets you detension the belts between the motor and the drive pulley. I'll drive this all the way through until it lifts the motor up as high as it can be. As if the bolts for the rear of the motor weren't in a confined enough space, the front are even worse. Alright, with all 4 bolts now started into the motor base, I can go around now and tighten them all down. With the motor bolts all snug, I can now turn my attention to the wiring. I'm going to reinstall the electrical box on the back of the machine that houses a breaker and a motor contactor. This is the original box that came on the machine. I did replace the contactor that was in it. It was pretty well degraded. There was something wrong with the breaker and it wouldn't stay connected. So I felt it was a better option to replace it with something a little more modern. The cord coming out of the top is wired to a 3-phase plug that I use to connect it to the phase converter. And then there are 3 screws that connect this electrical box to the back of the machine. I have the rotary phase converter running so we can do a test of the contactor. I have the red, green, and black wires that lead to the start-stop button connected to it. Pushing the start button engages the relay, which then provides power through the breaker to the motor, and then the stop button disengages the relay. Well, the next thing I need to do is connect the motor wires up to the circuit breaker. Just need to cut them to length and strip back some of the insulation. It doesn't make any difference in operation really which wire goes to where on the breaker. The only thing that comes into play here is the direction of the motor. The motor on the mill must turn in a specific direction. If I wire this up and it's running backwards, all I have to do is swap 2 of these wires and it will start turning the other direction. Well, with the phase converter running, we can do a quick test of the motor. It sounds pretty good. We'll stop it here so we can see which direction it is turning, and it is indeed running the wrong direction, so I need to reverse 2 of those wires.
One eternity later.
Well, with 2 of the motor wires reversed, let's go ahead and start it up again and see if we solved that motor direction issue. And sure enough, we have. It is rotating counterclockwise as you look at it. I'm so far really happy with how this is sounding and working. I do need to put some more grease in the bearings just to make sure it is sufficiently full. You always want to do this when the motor is running. Well, everything seems to be going great. The electrical seems to be running just fine. The motor sounds fantastic. You can hear the grease spinning around in those bearings a little bit. I'm probably going to come back here and revisit them and put some more grease in them on another day. Well, that's it for this video. I hope you found it at least a little bit interesting. If you did, do me a favor and hit that thumbs up icon. It certainly helps me with the Google Analytics and getting my videos suggested out there. If you're not a subscriber, please hit that subscribe button and hit that bell icon. As always, thanks for watching, and we'll see you on the next one.